Hey, grade 10. So we are now moving on to lesson 4 of unit 5. And as you can tell already, unit 5 is a long one. There are 8 lessons, about 7 or 8 lessons, and unfortunately, none of them are short because sometimes we've had other units where, some of the lessons are a little shorter. This one has no short lessons, unfortunately. So because of that, like I said, it's I would say one of the longest units. I wouldn't say the hardest, but longest for sure, and a lot of new content, but hopefully you're getting through this. So in this lesson, if you understood lesson 3 really well, then lesson 4 is really just an extension of this. We're just looking at how to solve trigonometric equations, which is kind of what we already started to look at. So this isn't actually anything completely new. We're just kind of extending on those ideas. So our learning objectives, so before we were looking at our Cartesian plane and looking at key definitions of a Cartesian plane related to acute angle. What we're doing in this case is we're determining the measure of 2 angles from 0 to 360 degrees and more. So right now in this learning objective, I say 0 to 360 degrees, but actually we could be looking at negative angles as well. But our focus will be mainly on the principal angles, but we can find other angles as well if we're given the value of the trigonometric ratio, okay? And then what we're going to do is we're going to look at how to solve more complex trig equations that will involve some knowledge of trigonometry, but also some knowledge of solving equations. That's all we're doing. So quick recall here. So on a Cartesian plane, we know that the casserole tells us the sign of the trigonometric ratio in question, whichever trig ratio we're looking at, depending on where the angle will lie, right? So it all depends on where the terminal arm will lie. The casserole will tell us what the sign of the trig ratio will be. And we saw that angles that have the same related acute angle will basically have the exact same trig ratios. The only difference is that the signs will switch, right? That's the only difference between them. So we have to consider, because there's different angles that have the same related acute angle but are on different quadrants but can still have the same trig ratio, that makes it more complicated because there's actually more than one answer when we work backwards. So because of that, we had to consider more than one possible answer. So for example, the cosine of 30 degrees, you can actually use your special triangles to figure that out directly. We know that the cosine of 30 degrees, this is 30 degrees right here. The opposite angle is 1. The adjacent side is square root of 3. And the hypotenuse is 2. So we know that the cosine of 30 degrees would be square root of 3 over 2. And we can actually, and we know it's going to be positive because it's in the first quadrant there. So, oops, CAST. Sorry, let me erase that. So we know, according to the CAST rule, that we have, if it's in the first quadrant, which it is, it's 30 degrees is right here, the cosine ratio will be positive, and then we know that in the fourth quadrant, the cosine ratio will also be positive. So we know that the cosine of 30 degrees is actually going to be equal to the cosine of 330 degrees. So that again makes it confusing, because we actually could have, if I give you that the cosine ratio is square root of 3 over 2, then actually you have technically 2 possible answers, 30 degrees and 330 degrees. So it makes it a little more complex. And another example, the tangent of 120 degrees we know is equal to 300 degrees. And how do we know that? Well, we draw we can draw out our casserole. We know that 120 degrees is right over here with a related acute angle of 60 degrees. And of course, 300 degrees is right here with a related acute angle also of 60 degrees. So we can see here that 300 degrees and 120 degrees lie in the second and fourth quadrant respectively. And according to the CAST rule, the tangent ratio is going to be positive in the first and second and third quadrant, which means that which means the tangent ratio is going to be negative in the second and fourth quadrant. And that means that the tangent of 120 degrees would be equal to the tangent of 300 degrees. And again, that complicates our question a little bit, because we'll actually notice that we're going to have multiple answers for one equation when we're solving this. So we need to consider all the possibilities. So how do we actually solve a trig equation? So a couple steps here, and I'll kind of go through them really briefly. First step is you isolate for the trig ratio, okay, by using inverse operations. So this actually isn't that bad. You're basically using your algebraic skills. You don't always have to do that. Sometimes it's already isolated for you, in which case just solve away. If your trig ratio is a reciprocal, then we talked about this, it's going to be much easier for you to work with your primary trig ratio rather than working with the reciprocal value, okay? Because you're more familiar with the primary trig ratio. Then what you're going to do is you're going to find the RAA, the related acute angle, and we actually brought this up in the last lesson, so this isn't anything new. As I said already, I would strongly recommend you ignore the negative sign if the ratio is negative before you find the inverse trig, before you use the inverse trig function. And we'll look at an example when you don't do that and how it tends to confuse your answer a little bit. Then you're going to determine the location of the terminal arms by using the cast rule, right? And which is what we did previously. We draw our cast rule to figure out which quadrant it's going to be in, which quadrant our terminal arm is going to be in. And then once you know which quadrant your terminal arm is going to be in, that's going to help you figure out what the principal angle is. And to find the principal angle, you simply use the fact that you know where which quadrant you're in, and you know the related acute angle to find your principal angle. And the last step here, if the principal angle is not in your given domain, or if you have other angles that you're missing, then you're going to have to find the coterminal angles. And we'll talk a little bit more about that. So once you find your answer, you may not be fully done. You may still have to find other answers as well. Okay. So quick little recap here. How do you find the principal angle in different quadrants? So we actually talked about this in the last lesson, but I wanted to kind of go over this again with a nice little diagram, which hopefully explains it a little better. So in this diagram here, instead of using RAA, they decided to use lowercase a for the related acute angle. And we can see here, obviously, the related acute angle is always positive, and it's always between 0 and 90 degrees. It's obviously acute. So in our first quadrant, we noticed that the related acute angle is actually the same as a principal angle. So the related acute angle is the same as a principal angle, right? In the second quadrant here, we noticed that the related acute angle and the principal angle are related in that the principal angle is simply 180 minus the related acute angle. We're simply just subtracting off whatever the related acute angle is to find the principal angle here. So here's our principal angle. And we notice that the related acute angle is, the principal angle is simply 180 minus the related acute angle. In the third quadrant, we notice that our related acute angle, which is this whole entire angle here, is simply going to be, or we can label it here at the end, it might make more sense. It's simply going to be the whole entire principal angle minus 180 degrees. And again, 180 degrees, because that's the closest degree to the x-axis there, right? So to find the principal angle, we simply take, I think I said it wrong there. I think I said subtract. That's to find the related acute angle. To find what I meant to say is if you want to find the principal angle there, you take 180 and you simply add the related acute angle. So it's 180 plus the related acute angle. And finally, for the last one, if you want to find the principal angle here, we simply take 360 degrees. And what we're saying here is that we're just finding out what we need to take away to get to the whole entire principal angle here. So that means that my principal angle is simply going to be 360 degrees minus the related acute angle. I recommend that instead of memorizing this, you actually try to understand how we can find the principal angle based on the drawings, right? It's just a matter of using a little bit of mental math. That's all it is, right? Not even mental math, just kind of reasoning skills here. So if you know what the related acute angle is, and you know what the closest marker points are, 180 or 360 degrees, you can easily figure out what the principal angle would be. So again, in the first quadrant, the related acute angle is equal to the principal angle. In the second quadrant, the principal angle is simply going to be 180 minus the related acute angle. In the third quadrant, it's going to be 180 degrees plus the related acute angle that's below it. And in the fourth quadrant, we're simply taking 360 degrees and we're just subtracting off the related acute angle that is remaining to get to 360 degrees. So we take 360 degrees minus the related acute angle to find the principal angle there. So again, I don't recommend memorizing that, but do try to understand how we can use this to figure out what the principal angles are once you know what the related acute angle is. So let's do an example here with the reciprocal trig ratio. So you're asked to find the angle between 0 and 360 degrees. And by the way, with all these questions, a lot of these questions, you're going to be told to find the angle between a certain domain, right? Because if we don't specify domain, then technically there are multiple answers. But it kind of goes without saying that normally we're interested in the principal angles anyways. So if you're asked to find the angles between 0 degrees and 360 degrees, if you're given this cotangent ratio, what I would do first is I would actually not work with the cotangent ratio. I would actually work with the tangent ratio. And the reason the tangent ratio is easier is because we're more familiar with this, and we can definitely use a calculator to solve this, right? So what we're going to do is we're going to rewrite the tangent ratio as -3/4. And again, how did I get that? I simply found the reciprocal. Now, don't make the mistake of switching it to a negative reciprocal. It's just a reciprocal, right? So that means that the tangent ratio is now, the tangent ratio of the angle is -3/4, and this is what we're solving for. This is now the new question we're interested in. And we also got lucky that the trig ratio was already isolated, so we didn't have to do anything extra. So now that we have the trig ratio on its own, what we're going to do is we're going to use the inverse trig function or the inverse trig ratio to find out what the related acute angle is. Again, I recommend you ignore the negative sign. So we're going to take, to find the angle beta in this case. And notice I'm using beta here. And the reason I'm using that is because I'm trying to find the related acute angle, right? And I've already mentioned this, that when I'm finding the related acute angle, I normally represent this with the symbol beta. So again, I'm not actually using the inverse trig ratio to find out what the principal angle is. I'm using the inverse trig ratio just to find out what the related acute angle is. It's not going to give us the final answer. It's just going to give us the related acute angle. So what I'm going to do is I'm going to take the tan inverse of 3/4. And this ends up giving us 36.9 degrees. Again, grab a calculator, just check that that's correct. I'm going to do that myself. So I'm just going to turn up the volume here. So I'm going to take the tan inverse of 3/4. That ends up giving us 36.9. Yes, that's correct. So now that I know what the related acute angle is, we still have to figure out the principal angles. So what do we know here? Well, we know that the tangent ratio is going to be negative. So if the tangent ratio is negative, that means that it is definitely not in the first quadrant, because the first quadrant is where all the trig ratios are positive, and it's definitely not in the third quadrant where the tangent ratio is negative. Sorry, it's not going to be in the third quadrant where the tangent ratio is positive. That's what I meant to say. So because it's not in the first quadrant, it's not in the third quadrant, then we know by default it has to be in the second and the fourth quadrant. So that means that our two angles are going to be, one of them is going to be in the second quadrant here where the tangent ratio is negative, and it's going to be in this other quadrant here where the tangent ratio is also negative. So if it's in the second quadrant, we use a little bit of math here. We know that the principal angle is simply going to be 180 minus the related acute angle. And luckily, we already know what the related acute angle is. It's 36.9. So we end up getting an answer of 143.1. And then to find this angle over here, the second principal angle, which I'll label as theta 2, we take 360 degrees and we subtract the related acute angle. And this gives us 360 degrees minus 36.9, which is approximately 323.1 degrees. And notice that these are the principal angles that we were looking for. There were no other angles that we had to consider outside of the domain, so we are done. So hopefully that kind of makes sense so far. Sorry, just wanted to make one little change here because I just realized that this picture is kind of blocking it, so apologize. There we go. Sorry, just changing where it is, just because it kind of gets in the way there. Okay, perfect. All right, so that is that question right there. So hopefully that made sense. What I want to briefly go over, and I won't go over this in too much detail, is what would happen if I actually kept that negative sign. So if I went this route, you could technically get to the right answer, but to be honest with you, it doesn't. I would probably deduct some marks because it doesn't make a lot of sense. While the answer is correct, it doesn't actually make sense for you to take the tan inverse of this, and you can put this in your calculator. You end up getting negative 36.9 degrees. Now, this isn't really going to help you because you're going to look at that and say, well, this is great, but I actually want to find the principal angle, right? From 0 to 360 degrees. So you could have found the principal angle by simply adding 360 degrees. and that ends up giving you an angle of 323.1. So that means one of your angles is 323.1, and we use the CAS rule. We know that 323.1 is around right here. 323.1 degrees is right here. Using your CAS rule, since you were finding the tangent ratio, we know it's going to be, the tangent ratio is supposed to be, is negative in this case, in this quadrant. So it's going to be in the other negative tangent ratio quadrant, which is going to be in the second quadrant there. It's not going to be in the first or the third. So then what you could do is you could figure out what the related acute angle is, which again, I feel like this is more work really. To find the related acute angle, you simply take 360 degrees, and you subtract 321.1 degrees. So you have to work backwards to figure out the related acute angle, which ends up giving you a related acute angle of 36.9. And then what you're going to do is use the related acute angle of 36.9 to help you figure out what the second related acute angle is, right? Which is in the second quadrant there. So you can get to the same answer, but to be honest with you, you'll notice that it's, in my opinion, it's more complicated, and it doesn't really make a lot of sense, right? Again, when you're finding the tan inverse, sine inverse, or cos inverse of a trig ratio, you want to make sure that it's positive, right? Because again, when we're trying to find out the related acute angle, we're only interested in angles between 0 and 90 degrees anyways, right? So we want to just ignore, again, pretend that all these are be positive anyways, right? The trig ratio is going to be positive anyways, so we ignore the possibility of it being negative. And again, this is just to help us find the related acute angle, right? So I hope that kind of makes sense there. Okay, let's do a couple more examples here. Let's solve for the given, let's solve for the given intervals here. So we have the secant of theta is equal to negative 3.5, and the angles between negative 360 degrees and 360 degrees, and 2 cosecant theta is equal to 3.5. So what we're going to do first is we're going to rewrite this as a primary trig ratio. So instead of writing the secant theta is equal to negative 3.5, I'm going to rewrite this as the cosine theta is 1 over negative 3.5, and we actually write this as negative 0.2857. And again, this answer is rounded. So my suggestion here is actually don't round it yourself. When you're actually putting this in your calculator, just figure out what 1 divided by 3.5 is directly. So this ends up giving me negative 0.2857, so on. But I'm not going to round my answer. When I write it down, I can round it, but when I'm actually doing the work, I'm not going to round it. So I'm going to show you on a calculator how to do this. So we take 1 and we divide it by 3.5. That's negative. And then we end up getting this answer here. So what I'm going to do now, as I mentioned already, I'm going to ignore the negative. Just ignore the negative sign there. So you can get rid of it by simply removing that number there. Or I can multiply by -1. It would do the same thing there. So if I want to find the cos inverse of this trig ratio here, because I'm trying to find out what theta is, what the related acute angle is, I'm simply going to take the cos inverse of this to find out what the related acute angle is. The related acute angle is 73.4 approximately. So now that I know what my related acute angle is, all I need to do now is figure out what the principal angles are. Well, if I know my related acute angle is 73.4, I'm going to use this to help me figure out what the principal angles are. So first of all, where are the principal angles? Well, we know that, and we look back at our cosine ratio here. We know that since it's cosine that we're looking at and it's negative, the cosine ratio is negative. We know for a fact that it can't be in the first quadrant. It can't be in the first quadrant because all the trig ratios are positive, and it can't be in the fourth quadrant because the cosine ratio is going to be positive in this ratio. So in this quadrant, so it's not going to be in the first or the fourth. By default, it has to be in the second and third quadrants. So if it's in the third quadrant, and I'm going to draw a picture up here. So if it's in the second quadrant here, we know it has a related acute angle of 73.4. Right? There's our beta angle. And then we also know here it has a related acute angle, or beta, of 73.4. So we're going to use that to help us figure out what the related acute angle is. So in our first step here, to find out what the first principal angle is, I'm going to do this in orange. Oops. So our first principal angle is going to be 180 degrees minus the related acute angle, or RAA. And then the second principal angle is going to be 180 degrees plus the related acute angle. So in the first principal angle in the second quadrant, we're going to take 180 degrees and we subtract off the related acute angle of 73.4, and we get 106.6 degrees. And the third quadrant, we're going to take 180 degrees and we simply add the related acute angle, which is 73.4. and then we end up getting a principal angle of 253.4 degrees. We were asked to find the angles between 360 degrees and negative 360 degrees and 360 degrees. So that means that we need to find the negative coterminal angles. So I'm just going to make a change here. I'm going to do this before I forget. And again, if you ever notice any little mistakes, let me know. I can definitely fix that. And I'm actually going to fix it now, because sometimes when I forget to fix it, then I let it go and then I totally forget. Sorry, let me just make a quick change here. Solving trigonometric equations. Okay, let me make this change now before I forget. I apologize, guys. You can just be patient with me. If this opens up. Okay, let me see. Okay, let me make this change right now before I forget. Perfect. All right, so then we end up getting, so going back to the lesson here. Okay. So then we end up getting our two principal angles, but then of course we still need to find the negative angles as well. So to find the negative coterminal angles, then all we're going to do is simply take our two principal angles and subtract off 360 degrees. If you do that, you'll be able to find the two other principal angles, right? Sorry, the two other coterminal angles, right? So we take 106.6 and we're simply taking away 360 degrees. Again, we do that because we're basically rotating clockwise to find out the other coterminal angle there. And we end up getting negative 253.4 degrees. And then of course the other angle was negative 253.4 degrees. And we want to find out the other negative coterminal angle. So it's going to be we're going to subtract 360 degrees, and that ends up getting us negative 106.6 degrees. By the way, it's just coincidence. People always ask that, they look at this and say, oh, do you just switch the signs? No, it's just coincidence that it kind of happened to work that way. It's not always going to be that nice or friendly numbers, okay? So again, there's the picture there to kind of help you understand the CAS rule. And sorry, I just want to make a small change here because I like the animation to be in the same order. I apologize, guys. I just want to switch this now because sometimes I totally forget later to do it. So I'm going to move this up. Okay, there we go. Just going to move that up there. Perfect. And I will also change that on the other one because if not, I will totally forget. Apologize, guys. Let me just make this change here. Okay, open this up. Okay. There we go. Ready to go. Sorry, it's my little pet peeve. I just want to make sure that the animation is actually correct there. Okay, I'm going to close this down. Okay, actually, I'll leave it open because you never know. I have to make another change, hopefully not. Okay, let's go back to our lesson here. If it works. No, it's not working. 1 second. Nope, that's not the lesson. Nope, that's not the lesson. There we go. Perfect. Alrighty, so hopefully that made sense. Now we're going to go to the next example here. So in this next one, we were given, so go back to the question here. We are asked to find theta when 2 cosecant theta is equal to 5. So the first thing you do before anything else, unlike the other question, what I want to do first is actually isolate for my trig ratio. So we want to isolate for cosecant first. So we're going to rewrite, and again, we didn't have to do this in the other examples because if you notice the trig ratios were already isolated. In this case, we want to isolate for the trig ratio first. So we want to divide both sides by 2 so that we can actually get the cosecant ratio by itself. And so then we end up getting the cosecant ratio is equal to 2.5, which I can actually write as the reciprocal. So I'm going to write that as the reciprocal primary trig ratio, which is going to be sine theta is equal to 2 over 5. And then this ends up giving me 0.4. So that means that sine theta is equal to 2 over 5 or 0.4. So what I'm going to do now is I'm going to use my inverse trig function to find the related acute angle. Luckily, the trig ratios, the inverse trig function of 0.4, which is kind of nice because then this ends up giving you a related acute angle that's actually equal to one of the principal angles. So you're kind of half done your battle. In this case, the related acute angle is actually one of the principal angles anyways, so that makes it easy. So again, using your CAS rule, if you know that sine is positive, then you know it's going to be in the first quadrant and the second quadrant. So we redraw this out, and we know that it's going to be in this first quadrant here, where beta is that one right there, and it's going to be in this quadrant right here. And this is beta right there. So if I want to find my two principal angles, so theta 1 and theta 2, should hopefully be pretty easy. all I'm doing is I'm simply, in the first one, the first principal angle is actually equal to beta. And the second one for theta 2, we're simply taking 180 and we're subtracting off the related acute angle. Okay, so we take 180, we subtract off the related acute angle, and then this ends up giving us 156.4 degrees. And then that is our two, there are two principal angles, so 23.6 degrees and 156.4 degrees. So for the second principal angle, again, doing a little bit of math, we know it's in the second quadrant, so all we do is simply take, to find that principal angle, we take 180 and then we subtract off the related acute angle. Right? Basically what we're missing to get to the 280 degrees, which is the marker, our target angle there. So now that we know our two principal angles, to find the other coterms is basically what we did in the other question. And notice that they're not the same answers, just different signs. It's different now, right? So we take 23.6, we subtract 360 degrees, that ends up giving us negative 336.4 degrees, and 156.4 minus 360 degrees ends up giving us negative 203.6 degrees. And you can always verify if this is correct, and I would definitely recommend that. So if you take 23.6 and then find the sine inverse of that, find the sine of 23.6 degrees. I take 156.4 and I find the sine ratio of that angle. I end up getting approximately 0.4. So this is looking good. And if I take negative 336.4, and then I find the sine ratio of that, I also end up getting 0.4. Let's just do one more. For this one, I'm going to take the sine ratio of 203.6 degrees. If you put this in a calculator, you should get approximately, let's just verify if it's correct, approximately 0.4. No surprise there, right? So I ended up getting the same sine ratio for that as well. So there are our four answers there. So again, in all these questions we've done so far, so I just want to backtrack it here. So just so you understand what we've done so far with these ones, at least, we noticed that we have actually not worked with special triangles yet. We had to, first of all, two things. We had to work with the reciprocal, with the primary, so we're working with the reciprocal trig ratio, which means that we switched it to its corresponding primary trig ratio. That was the first thing we did. And then we also noticed that because they weren't special triangles, we had no choice but to use our calculator to find it. So what I want to focus on now is how to do this without a calculator. So in these examples here, what we're going to do is we're going to find the exact angles. And when I say exact angles, that means that you're going to be using your special triangles, okay? And again, ideally, you're doing this without a calculator. I think I mentioned this already, Ms. Powell mentioned it for sure, that we are going to have a small quiz this week in class where you are not using a calculator, no phones, no electronics, nothing, okay? It's just your brain, right? So you want to make sure that you're able to do these questions without a calculator. University level math, there's some exams where you're not allowed calculators at all, right? And same with IB as well. Okay, so let's look at the first one here. So we're trying to solve this equation, 2 sine theta is equal to -1. So first thing with this question, we haven't isolated for the trig ratio. So our first step is to simply isolate for the trig ratio. So we do that by simply, I'll just rewrite the equation so you see it. I'm going to divide both sides by 2 so I can isolate for sine theta. And then I end up getting sine theta is equal to -1/2. Perfect. So now that I know that sine theta is equal to -1/2, I obviously noticed that, I noticed that this kind of looks like our special triangle. The only difference is that we're still following the exact same steps as before. We hopefully recognize that this really just is representing a sine ratio where the opposite side is 1 and the hypotenuse is 2. So you want to think to yourself, going back to my special triangles, which angle has an opposite side of 1 and a hypotenuse of 2? Hopefully you recognize that as 30 degrees, because 30 degrees is directly across from the small side length of 1, and the hypotenuse is 2. So that means that theta must be 30 degrees. Now, I want to be clear on this. It's not theta, it's actually the related acute angle that we just found. So we still haven't found the actual angle yet. So really what we're doing is finding out what beta is. And again, without a calculator, you know that the sine inverse of a half, you're basically asking yourself what special angle has an opposite side of 1 and a hypotenuse of 2. We know that's going to be 30 degrees there. So our related acute angle is 30 degrees. Now that we know what our related acute angle is, we can easily find our principal angle. Well, let's start with the casserole here. So according to the casserole, we know that the sine ratio is going to be positive in the first and the second quadrant, but because we're told that the sine ratio is negative, we eliminate these two options, right? It can't be in the first or second one because the sine ratio is positive there. So by default, where does it have? It's because the y coordinate in the third and the fourth quadrant is negative. And remember, sine ratio looks at the y coordinate there. So that means that my two principal angles are going to be right here. So here's my first principal angle, and here's my second principal angle. So to find my principal angles, I'm simply going to be subtracting off, adding on the related acute angle to 180 degrees to figure out what the first principal angle is. And then in the second principal angle, in the fourth quadrant, I'm going to be subtracting off the related acute angle from 360 degrees. So hopefully that makes sense so far. So to find my first principal angle, I take 180 and I simply add the related acute angle of 30 degrees, and that gives me 210 degrees. And in my for my second principal angle in the fourth quadrant, I take 360 degrees and I simply subtract off 30 degrees, and that gives me 330 degrees as a principal angle. Now that I have my two angles there, I still want to find my negative coterminal angles, and I think most of you are okay with this. You know that you just have to go one rotation clockwise to find the other angles. So for example, if I know that the one principal angle is 210 degrees over here, if I want to find a negative angle, I simply go clockwise around. And I do that by subtracting off 360 degrees, and I end up getting negative 150 degrees. And of course, the other angle that I can find is taking 330 degrees minus 360 degrees, and that gives me negative 30 degrees. So there are my four angles within that domain that was given to me of negative 360 degrees and 360 degrees. And I forgot the degree symbol there. I apologize for that. Okay, so I'm hoping this is making some sense so far. I know there's a lot of details here, and I apologize for that, guys. There's a lot to learn, I know. And by the way, I just realized I think I'm forgetting the degree symbol for every second one. I must have copied it from the wrong one, and I forgot the degree symbol. So unfortunately, they're all a little off, but just remember that both of them have the degree symbol there. Okay, let's look at the next one. So in the second example here, let me just go back. In our second example, we have 5 cosine theta is equal to, minus square root of 3 is equal to 3 cosine theta. So I'm going to write this down. So 5 minus cosine theta, 5 cosine theta minus square root of 3 is equal to 3 cosine theta. Okay, so first thing I need to do is, again, isolate for my cosine ratio, right? What am I trying to isolate for? The cosine ratio. That's what I'm trying to get on its own. So the first thing I would do is I would, just like before, kind of like collecting like terms, I want to bring all the cosine theta terms to one side. Again, imagine, I'm going to give you a different explanation. Imagine if the question had said 5x minus 3 is equal to 3x. This is a much easier example, but you follow the same procedure. You want to move all the x's to one side. So you get 5x minus 3x is minus 3 is equal to 0. I just bring over the 3x. And then, of course, my next step is I bring the 3 over. So then you get 2x is equal to 3. And then my last step here is I divide by 2 to isolate for x. Well, it's the same idea here. The only difference is that slightly more complicated expression, but it's the same concept. I'm going to bring all the cosine theta to one side. I'm going to treat them as one like term, right? Or yeah, like terms there. So I subtract off 3 cosine theta, and then ends up giving me 0 on the right hand side. So I end up getting 2 cosine theta minus square root of 3 is equal to 0. Now, why did I add square root of 3 on both sides? Well, I did that so I can move that square root of 3, the negative square root of 3, to the other side. So to get rid of the negative square root of 3, I add square root of 3. And by doing that, that's eliminated. But remember, whatever I do to the left, I do to the right. And this ends up giving me 2 cosine theta is equal to square root of 3. And then, of course, my last step here, I divide by 2 and so on. And then I end up with square root of 3 over 2 is equal to cosine theta. Okay, so now what I'm going to do next is I'm going to try to figure out what the angle is going to be, so that what the angle theta would be, so that the cosine ratio is square root of 3 over 2. So again, I hope you recognize that this is coming from one of the special angles. The special triangles, which means that it's a special angle that we have here. And specifically because it is positive, we know the related acute angle is going to be one of the principal angles anyways, right? So whose adjacent side is square root of 3. Let me write this out. Whose adjacent side is square root of 3, and whose hypotenuse is 2. So let's do a picture to figure this out. Okay, so oops, that's a really bad picture. So which angle has an adjacent side that is square root of 3, like that, and a hypotenuse of 2? Hopefully you recognize that that means that the opposite side is 1, and that means this angle has to be 30 degrees. So hopefully everyone recognizes that that is 30 degrees. So if it's 30 degrees, that means that that's my related acute angle, right? And that's my beta angle. And I'm going to use that to help me find out the principal angles here. So using the CAS rule, I know that, and let me erase this also, it's going to get messy. I use my CAS rule, I know that because the cosine ratio is positive, it needs to be in the first quadrant and the fourth quadrant, not in the third, not in the second or third. And that means that my two principal angles are going to look something like this, where the related acute angle is 30 degrees. Right? So if I want to find the first principal angle there at the top, all I need to do is simply take, well, that's going to be equal to the related acute angle, so that's easy. And my second principal angle, I take 360 degrees, and I simply subtract off whatever the related acute angle is of 30 degrees. And that gives me a principal angle of 330 degrees right there. So there are my two principal angles, 30 degrees and 330 degrees. And in this example, they didn't ask for the other coterminal angles, so we just leave it as it is. And that's all you have to do there. So again, we always go back to the question and just check the domain. But in this example, the domain was 0 to 360 degrees. So we got lucky there. So we just leave it as is. We're already done. So I'm hoping that kind of makes sense. So what I want to move on to next is looking at the primary trig ratios for multiples of 90 degrees. So if you're finding the trig ratio multiples of 90 degrees, again, I know some of you already asked me, you said the special triangles all had 90 degrees. So how come we didn't do the primary trig ratios for 90 degrees? So any of the trig ratios for multiples of 90, you can draw a triangle. You could try to draw a triangle, but it wouldn't really make a lot of sense. It's actually not going to make too much sense when you try to draw a triangle with it. The best way to think of it is to think of it in terms of where its position is on a unit circle. So a unit circle, I just want to review, is where the radius is equal to 1, right? The radius is 1 in the unit circle. So if we picture a unit circle and imagine going along the circle and we have different x, y coordinates. So just imagine I have x, y coordinates here. I just keep moving along the circle, right? And essentially what I'm doing is I'm trying to identify what the trig ratios are as I move along the circle from 0 degrees all the way up to 360 degrees all the way around. So let's start off with the first one, 0 degrees, which is the same as 360 degrees because they're coterminal angles. Well, at 0 degrees right here, when I start rotating around, I noticed that I'm going to start at an x-intercept of 1 and 0. Why do I start at 1 and 0? Well, the x-intercept here is obviously going to be, is going to have to correspond with the fact that the radius is 1. And the y-coordinate, since we haven't actually moved out vertically, we still have a y-coordinate of 0. Then really what our x-coordinate is, what our coordinate point, our coordinate pair point at this point at 0 degrees is going to be 1 and 0. So we're going to have an x-coordinate of 1 and a y-coordinate of 0. So that makes sense because it's the x-intercept in this case. If I go to 90 degrees, what I notice is that I have the point 0 and 1. And again, why is the point 0 and 1? Well, we can just do a little graph here. Hopefully you can see it. The radius is still going to be 1 all the time. The x-coordinate in this case is going to be 0 because the horizontal distance from the origin is 0. And the vertical distance from the origin is 1. So this is going to be my y-coordinate there. At 180 degrees, my x-coordinate, or my horizontal distance from the origin, is going to be -1. Again, it's -1 because it's to the left of the y-axis, and the vertical distance is going to be 0 from the origin, right? And again, my radius is 1, by the way. So it's been 1 the whole entire way. And then the last step here, the last angle that we look at is 270 degrees. My radius is always 1, and my x-coordinate is going to be 0 because the horizontal distance from the origin is 0. And my y-coordinate is -1. So this is my x-coordinate, this is my y-coordinate. So I'm going to use that to help me identify what the sine, cosine, and tangent ratios are. So let's start with 0 degrees here. Well, I know my sine ratio is going to be y over r. And in our case, the y is 0, the radius is 1. So that means the sine of theta for 0, when theta is equal to 0 degrees or 360 degrees is going to be 0 over 1, which is 0. Okay, pretty easy. What about the cosine ratio? The cosine ratio is going to be x over r, and our x-coordinate is 1, and our radius is 1. So it's going to be 1 divided by 1, which is 1. Our tangent ratio is going to be y over x. In this case, it's going to be 0 divided by 1, and 0 divided by 1 is 0. So what we notice is that we have a sine ratio of 0, cosine ratio of 1, tangent ratio of 0. Do I recommend you memorize this? No. I recommend that you memorize this picture, which will then help you to understand exactly how you can find the sine, cosine, and tangent ratios. Because to find the sine, cosine, and tangent ratios, all I'm doing here is simply using my x, y, r ratios to figure that out, right? Which we learned about the last lesson. Okay, for 90 degrees, sine ratio will be y over r, which in this case is going to be 1 over 1, and 1 over 1 gives me 1. My cosine ratio is going to be x over r, which is 0 over 1, which ends up giving me 0. And my tangent ratio is going to be y over x. And in this case, we have 1 divided by 0. And what's 1 divided by 0? Well, it says undefined in a calculator, but really what this is actually going to look like is infinity, because really what you're doing is you're saying that if I take 1 and I'm dividing by an think about it this way, if I take a pie or a cake, and then I tell you, I want to split this, I want to figure out how many crumbs can fit inside of that cake, right? So if I were to break that cake down into crumbs, how many crumbs would there be? Well, it's an infinite number of crumbs because it's so tiny that there's there's an infinite number, right? So and again, for now, let's just leave it as undefined, but you're going to learn, I don't want to go into too much detail. This is a bit more complex, but you're going to learn more about this when you take advanced functions. You're going to learn about something called end behaviors and vertical asymptotes and what happens when we go towards certain values, right? We see that we actually end up getting asymptotes, which are basically values that we never fully reach, right? So talk a little bit more about that. For 180 degrees, we realize that the sine ratio is going to be y over x, which is going to be 0 divided by 1, and 0 divided by 1 is 0. So the sine ratio for 180 degrees is 0. The cosine ratio of 180 degrees is going to be -1. And again, this is the radius of 1, right? So we got -1 over 1, which is -1. And the tangent ratio is going to be y over r. So it's going to be 0 over -1. Sorry, y over x. Sorry, that's what I meant to say, y over x. And so we get 0 divided by -1, which gives us 0. And then our last example here, for 270 degrees, we notice the same idea and nothing too special here. This is our x, here's a y coordinate. So, sorry, just going back here a little bit. Yeah, so I had color coded the angles, just wanted to make sure you saw that. Oops. So in the last example here, we know that we can take, to find the sine ratio is 270 degrees, I take y over r, so it's -1 divided by 1, which is -1. The cosine ratio is going to be x over r, which is 0 over 1, and 0 divided by 1 is 0. And the tangent ratio is going to be -1, which is a y coordinate divided by x, which is 0. And that ends up giving me, once again, an undefined value. And I don't want to go into too much detail about this, but not only is it not undefined, but actually it's even more special. It's -infinity. I don't want to talk too much about that for now. I'll kind of leave that for your grade 12 advanced functions class. But essentially all you need to know for now is that the tangent ratio, the cosine and cosine ratio, we can solve it we can find the sine and cosine ratio for any angle, but for the tangent ratio, we're going to run into some issues with certain angles. So we actually cannot find the tangent ratio for all angles. So once again, going back to the topic of cosine and sine as functions, the domain is actually unlimited. We can we can find the sine ratio, cosine ratio of any angle, but for the tangent ratio, we actually can't find the tangent ratio of all angles. We're going to be a little more limited. So there's going to be some restrictions. If we go back to, and again, nice little interesting tie in with what we talked about in rational functions in unit 2. We talked about restrictions, and we're going to see that tangent functions have restrictions. Okay, here's a bit more of a challenging question. Solve this trig equation, solve this. Well, first step is isolate for the tangent ratio. So we're going to do that by trying to get tangent by itself. Trying to get the theta by itself. Now notice that there is a 2 in front of the theta. So really what we're doing is finding the tangent of 2 theta. So what I would do first is just try to isolate for the tangent, try to isolate for 2 theta first. So we're going to divide by 4 on both sides. And we do that so that we can actually get tangent of 2 theta on its own. So then we end up getting tangent of 2 theta is equal to 1. And then what we're going to do now is try to figure out what 2 theta is equal to. So in our next step here, what we do is we actually treat 2 theta as if it's one variable on its own. So this is where it gets a little bit tricky. This is something a little bit new. You're actually going to treat 2 theta as if it's just one variable on its own. It's a bit more of a complex situation, and because this is getting closer to the grade 12 material, but I still like to introduce it to you now, right? So that you are at least a little more familiar when you see it next year. So what we do when we introduce a variable is we rename it. We're just going to call it something different. We're going to call it angle alpha, okay? So let's treat 2 theta as if it were just one big variable alpha. So if that's the case, then that means that the tangent of alpha is equal to 1. So how do we find out what this angle alpha is, quote unquote? Well, we can use our knowledge of special triangles. So we're basically asking ourselves, what angle has a tangent ratio of 1? Now remember that you don't actually see this, but it's a tangent ratio of 1 over 1. I hope you recognize that as the 45 degree, 90 degree triangle. So my opposite side would be 1, and my adjacent side would be 1 for either one of the 2 angles. And that means that alpha needs to be 45 degrees. You could also use a calculator as well. So you could do the tan inverse of 1 and you get 45 degrees. So now that we know what the related acute angle is, now that we know, yes, exactly. Now that we know what the related acute angle is for this angle, which is 2 theta, we still have to go through the work of finding the principal angle, right? So we're not done with this question yet. So what we do next is we say, well, I know how to set my 2 principal, let me erase that here. I know that my 2 principal angles are going to be in the first quadrant and the third quadrant. Why is it in the first quadrant? Well, because the tangent ratio is positive, so it has to be in the first quadrant. And I know it has to be in the third quadrant because the tangent ratio is positive. Only the tangent ratio is positive in the third quadrant. So it's going to be in the first quadrant and in the third quadrant there. So we have 45 degrees and 45 degrees right there as the related acute angle. So now that you know what the related acute angle is, how do you find the principal angle? well, this hopefully isn't too bad. We've done this a couple times now. The first one's actually pretty easy. It's equal to 45 degrees because it's equal to the related acute angle. The second principal angle is simply going to be 180 degrees plus the related acute angle of 45 degrees. So we simply add on the related acute angles. So that gives us 225 degrees. So there are our two angles. And again, the two angles that we found are actually not the final answer. Unfortunately, what we did was we did all this work to figure out what 2 theta was equal to. But remember, the question didn't ask us for 2 theta. It asked us for theta. So we need to solve for theta in this case. So what we know so far is that alpha, which is 45 degrees, is equal to 2 theta. And again, we know that because we actually set up this new variable like that. We let alpha be 2 theta. And then we also know that alpha, which is 2 theta, is equal to 225 degrees. So how can we use this to solve for our missing angle theta? Well, actually, this part isn't too bad. If we know that 2 theta is equal to 45 degrees, how can I find theta on its own? I divide by 2 on both sides, and we end up getting theta is equal to 22.5 degrees. And then how do I solve for theta on its own here? Well, I take 2 theta is equal to 225 degrees, and then I divide by 2 on both sides, and I end up getting theta is equal to 112.5 degrees. And there are my two principal angles. Now, technically, there's more to this question, and I don't want to throw you off even more, but actually you have to consider 2 more answers within that domain. And the reason for this is because we technically have only gone what we have really done by taking 2 theta, and again, this is more going into unit 6, because we have actually, if you want to think about transformations, what we really did is we actually have a horizontal compression by a factor of a half, which means that the length of, and again, this is more unit 6 material. I don't want to make this too difficult, but think about it this way. Our function is moving twice as fast. So because we can actually reach more angles that have this equation satisfied, right? Again, this is going a little bit more advanced, but for now, I'm just going to say that these are your 2 answers, and there's actually more answers that we need to look for. But again, I'm going to leave this for unit 6, and we'll talk a little bit more about that later on. But again, this more challenging question. So there are the homework questions. Just so you know, part B, I actually wrote 1 ABD, but I'm actually going to make that extra challenge questions. I don't think I'm going to put that on the test necessarily, but I want to at least try them out, okay? They're just kind of, like I said, more challenging questions, just fun challenge, right? If you want something a little more difficult, try that out. All right, and that is everything for now.